Okay. Yeah. Welcome everyone to our webinar series, episode 12. Today we have Bart and Sies, who will present us the talk on how to design regenerative systems, integrating the ecology and systems engineering. Yeah, without any further ado, I would just like hand it over to you and you can introduce yourself and get started.
Yes. Okay. Thanks, Hamza.
And I
All
think
right, Sis, can you share?
yeah. Oh wait, I just need to change my privacy settings for some reason. That makes sense.
Okay.
Just turn them on.
Okay. So, well, my name is Bart van Luling from the Netherlands, together with Sis, my colleague at Dutch Boosting Group. I'm also the currently the technical director for the Dutch chapter of Incosi. I have a background in civil engineering. Worked at the Ministry of Infrastructure for many years, but already many years ago, where we implemented systems engineering in the Dutch infrastructure sector. And I think around 2013, together with a few other colleagues, I founded Dutch Boosting Group, and we are mainly implementing and applying systems engineering in, well, many projects for different clients in different sectors. And maybe Sis, you can go to the next slide. That's
Okay,
a bit
sorry.
of an older picture, but this is who we are. And I think currently we are about with 75 colleagues, doing much more than only systems engineering, but always doing it on a basis of systems engineering and systems thinking. And we like to work on projects that contribute to our societal challenges, contribute to the environment. And basically, we call this doing a meaningful work and using a systematic approach to make sure that we achieve the goals that we have in projects. And always with dedicated professionals who try to uh, yeah bring the client a step further in professionally applying systems engineering. Steve, maybe you can also shortly introduce yourself, what your background is.
Yes, sure. Definitely. Yeah, I'm Sies, 35 years old, ecologist by background, but then further thought, okay, I can try and save nature, but if we humans don't stop changing the way that we interact with our natural environment, it's, as we in Dutch say, it's mopping the floor with the tap open. So it's tackling the symptoms and not the foundational things. So then I studied further, also did a master's in circular economy. So also start the business side of things, so that we can basically also gap the bridges. And I've been working for a Dutch Boosting Group now for 5 years. Wanted to learn the systems engineering approach, because I think if you understand systems engineering, you understand a lot of how to develop any system. And I've been working a lot on how to integrate that universal methodology with a universal look on how you can integrate sustainability and regenerativity in there as well. I like sports, I like going outdoors, and that's about it, I guess.
Yes. And well, past years we also worked a lot together on trying to combine Cesar's knowledge about ecology and my knowledge about systems engineering. And I always like to make things practical. So we'll end also this presentation with a practical model that we try to use in our projects, and do a small exercise with that. So I'm also very curious what your feedback is on that.
Yeah.
If you go to the next, Cies, then, first Cies will start to explain a bit more on the difference between being sustainable and being regenerative, the problems we have today, and how we can apply ecosystems thinking, as we call it, to those problems. And then we will work towards what we call our sustainable systems engineering model, and do the case study with that. So that's a bit of the program today. So we will try to keep our presentation short so that we have more time for the exercise and discussions, but no promises.
Yeah.
All right, so Sies will start with a bit of background and theory.
Yes, indeed. And it's first a quick question to you guys. Does anyone know the difference between sustainability and regenerativity?
Yes, one is continuous and iterative, and it's like nature works.
Yeah, it's more like I often say that sustainability is about doing less harm, about decreasing the impact, negative impact, while regenerative is actually making things better. As actually you can see here, sustainability is like, okay, we have to be net zero CO2 emissions by 2050, but it's not that we abstract more carbon dioxide from the atmosphere and put into the ground, for example. So regenerative is basically taking things a step further. And it's very important because that opens a new space of where we can think of finding not only functions, but also solutions. So it opens a different paradigm of how we look at systems and how we think about systems.
Yeah. Yes.
And for you guys, I also wanted to check, of course, like, okay, is this topic relevant in systems engineering? Or is it? So I gave it a Google and I looked at the AI overview, and it says here that regenerative systems thinking is becoming critically important to modern systems engineering, shifting the goal from simply reducing harm, sustainability, to creating net positive, restorative impacts on human and ecological systems. So ChatGPT thinks it's relevant, so I think that's at least a good thing. And by looking nowadays what we actually do, we found a picture which basically sums everything up, is that we have developed our human technology and all our systems basically, and we use and see nature as an object. How we put it into squares, lines, and boxes, and we basically use it that way. But by doing so, we also basically then destroy the system where we fully depend on. So like a wise philosopher, Alan Watts, once said, he said, human beings on the planet are like apples on an apple tree. We come out of this planet the same way as apples grow out of an apple tree. And if we don't keep the apple tree healthy, we have unhealthy apples or no apples at all. So it's very important that we stay connected with our natural ecosystem. So then sustainability related problems. Normally I ask the group to name these different problems, but I think that will take a little bit too much time. So what we see on the left top corner, in the Netherlands, we had a nitrogen crisis because of the amount of livestock that we have and stuff. So the highest judge once said, okay, this is enough. You can't put more nitrogen in the environment. And that has caused a lot of problems with the building of new houses, etc. So it's breaking laws. The second picture on top is basically that we reduce our water resources that we have on the planet. The one on the right is biodiversity loss, climate migration on the left bottom. There's millions of people that move and migrate because of climate problems. I think more than half of the people that migrate basically do it because of those reasons. Then on the bottom, we have global warming. And on the bottom right, we see that resources like metals, steels, critical materials, that prices are getting higher and that demands are also high up, but the amount that we have is decreasing. So there's a lot of problems that we are facing in this part that we have to tackle. And that's basically ecosystems thinking that can help you basically tackle these problems. But before that, Bart is going to tell you something about our systems engineering model that we use and what actually the basis is of sustainable systems engineering.
Yeah, what we try to do is how can we connect these problems to our systems engineering approach, and this is what we call our pyramid model or life cycle model. Of course, there are a lot of models on how to do systems engineering. You can also recognize the V model a bit in the middle, where we say, okay, the complex systems that we develop, we have a process where we gather stakeholder needs and analyze those, translate this into requirements, what we need to achieve, functions that we need to fulfill, the performance that we want to achieve, and then look in the design phase how we can solve this in the best way. Which system do we need, and how do they look? What are the trade-offs we can make, and what are the design choices we can make? And we do that at different levels of detail. So that's an iterative process with continuous verification and validation if we still comply to our requirements and fulfill the needs of our stakeholders. And when we reach the point that we have enough information that we can start fabricating all the parts of our system and integrating those to the completed system that we can hand over to the organization, and then we can still verify and validate at each level of if we achieve these and take the system into use, and maybe during the operational use of the system have some changes or adjustments of the system, and we call those the smaller V's. We sometimes call this also the heartbeat of asset management, where during the life cycle you have some smaller V's where you have to change things again in your system. And by this approach, we try to connect at each level the requirements that we need to fulfill, the functionalities that we need to fulfill, and the design choices that we made. So how do we make sure that in this whole process we can develop systems that do less harm to our environment, or even contribute, as he said, by being regenerative? So in the next slide, if you can go to that one, Sies. Kind of flatten the process. So this is just one level where we say we go from stakeholder needs to system requirements to design choices. We verify if they comply. We build the system. We verify if it complies to our specification. And also when we reuse systems or adjust them, and all the time validate if it fulfills the needs of our stakeholders. And what we try to do is that we add to the stakeholders our planet. So we say basically, if we look at the problems of today, we should include the planet as the biggest stakeholder and make sure that systems that we develop contribute to the function of our planet. And by that, also improving our human well-being. And it enables us to develop more regenerative systems. Also depending, of course, on the ambitions you want to set as an organization. So you can use it to be more sustainable or to even be more regenerative. And this we translated into a model. But before we can go through to the model, we really should understand what it means if we say we want to contribute to our planet. What are all the aspects that are important there? And luckily for that, we have Sies in our company, who has an ecological background and knows a lot about our planet.
Yes.
And this starts not just by systems thinking, but what we call system of systems thinking.
That's correct, Bart, indeed. Yes, because if we look at our planet, like like Einstein once said, if you can't explain it simple, you don't understand it well enough. And I think I found a way of how to explain it simply, but from that on, also be able to go deeper down and deep dive. But I think it's very essential that we understand the essentials of ecosystem thinking. Like, how does it interact? What parts does it consist of? And how do they relate to one another? Because if we have that overview, then we also understand how we can basically then build systems which integrate those ecosystem functions. And then we basically create and build systems which actually contribute to our society and also to our environment, and therefore also to our future generations. But to understand an ecosystem and also the important elements to steer basically when we talk about sustainability or regenerativity, is that we have to zoom out to our system of systems. And the reason why we have to do so is because this system consists out of two elements, and you can break it down to one, but that's basically energy and materials. Like our whole planet and our whole universe is basically always an interaction. Yeah, you can basically hit it down to only energy, but we see our planet basically based on energy and materials. Everything is made out of it. Also, every system that we build has these two components. Without these two, you can't build any system. So they're therefore fundamental in how we use these. But then if we zoom in on our human planet, that's just not energy and materials. It's a more complex system. And that means basically that our planet Earth is an ecosystem. And yeah, this is also something normally I do this as a sort of small group assignment, because what is an ecosystem actually? And so like a lot of people know about the word, but they don't actually know what it means. And in the simplest form, it's basically an ecosystem is a system in which abiotic and biotic factors interact. That's also the reason why Mars doesn't have an ecosystem, because it doesn't have the biotic factors, or in other words, the living things on it. So by breaking it down into these things, it's also very important to understand that the abiotic factors are like a preconditionary for the biotic factors. And the reason why we don't find trees, for example, in Antarctica is because the abiotic factor temperature there is not high enough for trees to grow there. So therefore, we are very related and dependent on the abiotic factors. But for example, through climate change and changing we're changing the abiotic factors, and therefore they're becoming more unstable, making it for us, and then it comes back again. If you look at to resilience, the more unstable our natural ecosystem is, the more resilient your system has to be. So the more difficult you're making it for yourself. So basically how you can, the first dividing of how you can divide an ecosystem. But if we look at our, a little bit further, we can decompose it further. And that means that if we decompose our planet or Earth, it basically consists out of energy and materials. There is then the abiotic factors, which is always an interaction between soil, water, and air. And if that interacts with another in a certain way, there grows a biotic system. And they're all independent on each other. And that's very important to understand. And it's also important to understand that those are spontaneous processes. That nature does their thing because it just goes that way. And we have to live within that natural cycle. So we have to understand it and adapt to it, and basically integrate our systems within it if we want to keep it sustainable. So what is then the relation then with sustainability? Well, what we've done in the past is basically that we have developed our own vision of the world, and we've developed all our economic things and products and cars, systems, etc., but only for ourselves. So we had a very high, not a high over, but an ego-like vision. Okay, the planet is there for us to use. But now we see the more we do that, the more we basically also destroy the system where we then depend on. So we have to make a mind shift of how we can basically not only use the planet for our own benefit, but how can we actually improve the ecosystem of the planet so that it becomes so stable that it becomes very easy for us to integrate the systems that we build within that natural ecosystem. So how can we basically shift from just mining and using to basically use a sort of gardening and actually creating value that adds towards a better environment and better human well-being. So if you take the word sustainability, it's and you look at the definition, then it often comes down to three aspects called people, planet, and profit. And why is that so? Because like these three elements, they basically scope the whole envelope of our environment. Because our whole planet, you have an environment on there, we have our human population, and we have an economy. And actually, that's everything that there is. So by knowing that these three, if you use these three, you have an integral perspective on how we basically can fully understand the whole planet. But it's very important how these three aspects relate to one another. And I've been working on this when I was in my studies. Like I was like a teacher of mine, a lecturer, he told me always like, no, they have to be even together. And I was like, but it's not possible. Like there has to be a deeper systematic view on how those three elements interact with one another. And I came to different visions on this. And the first one that we basically, and this is basically how we use it in our capitalistic economic system, as we put the economy on front. And we use our environment and humans basically to feed the economy and to make the economy bigger. But it's not basically improving the environment or our human well-being. Maybe our welfare and the amount of goods and stuff that we have, but not basically really our well-being always. So we elaborated on this further. And then we have basically this model, which basically says, okay, they have to overlap and they have to be integrated. But what you get with this is that projects, companies and stuff start to cherry pick. They just pick some of the values from every circle. And then they think, oh, okay, they put the label on it, it's sustainable. But if you look at it on the bottom line, it's not sustainable. It's just a little bit doing less damage than it used to do before. So if you really look at it from a systematic view, then you will see that our environment is the basis of everything. And we humans live within that environment and we are part of it. And because we can live there and work and do our thing, we create an economy. So, and this is what we call a nested model. And within that, our environment is a prerequisite. So it means that if on the long term, if you destroy that environment, you eventually will destroy yourself as a species, or become harder and harder to thrive as a species. So it's therefore a prerequisite. The second thing is that humans, when we talk about humans, we talk about human well-being. So how can we actually feel more happy? And we're not going to go into a lot of detail with that because we're focusing on the environment planet and on the environment. But we're also separately working, okay, how can we basically operationalize human well-being? What functions do we need for that, for human beings to thrive, actually? So improving human well-being while the environment is a prerequisite is your goal. And then last but not least, the economy is basically, it's not only the money that we have, but it's the assets, it's the objects, it's the things in systems engineering that fulfill functions. And those functions should actually benefit our human well-being and our environment. And if we do so, then we can actually create real value that adds to our the well-being of our lives, and also create a future for a future generation to live on a sustainable and good planet. So this is basically the most essential way that if you develop systems, this view should be your basis, theoretical basis, I say, because in practice, it's not always, due to lots of technical reasons, financial reasons, possible to really build a system that is regenerative. But if we don't use these these ways of thinking, it's going to become very difficult to build systems that are really sustainable. And I really think that we're only going to do more harm and get more and more issues and problems. So how to operationalize this basis then? For that, we've also used the Sustainable Development Goals as part, in which you can see here, of course. And they also had a problem because it's just a set of 17 goals. But what is the integration of the relation with all these different goals together? Because what you see here as well is that a lot of companies, they just pick a couple of sustainable development goals. And I've asked multiple companies, but hardly any of them choose the SDGs live on land or live on water. So therefore, biodiversity is always degrading. And that's basically the fundamental system where we as a human society also depend on. And that's becoming problematic. So what have they done? And this is from the Stockholm Resilience Center. They've taken that nested model. So it's a little bit of a different view, but it's a similar concept where they see the biosphere here, or our environment, is basically the foundation of everything. And the SDGs, every company or every system should take those SDGs into account and operationalize them if you want to build a sustainable regenerative system. Then you have our society goals. Like all those goals, they contribute to better well-being. It's about education. It's about health. It's about having no hunger, quality education, sustainable cities, etc. And the last part, again, is the economy. Those are the means basically that we use to fulfill the goals in the society and the biosphere range. And again, well, using a model like this, you can again use a way better systematic view on, and also an integral view on how sustainability works. And there's two aspects here, which I find which are underrated, and those are resources and materials and energy. And the reason why I've put them underneath here is because those two are the ones that have the biggest impact on our ecosystem, and sometimes also on local communities or visits. So how we basically spend our resources and our energy and what functions we fulfill with it is very essential in how we build our future systems and how sustainable they will be. Because the more we need, the more impact of the resources, energy, the more impact we will have. And now how to also check a little bit on why these ecosystem parts basically are essential. So with that meaning energy and resources, the abiotic factors that we have, and the biotic factors, is that you can always combine them, or you can combine them with legislation. So for example, if we look at energy and resources, we have the European Action Plan, Circular Economy, and the Green Deal, meaning that in 2050, our whole economy has to be circular, because the dependence on materials that we have will be so big then that we won't be even able to keep continuing creating these systems. We have the Green Deal that we also have to be climate neutral by 2050. If we look at soil, water, and air, we have a soil strategy, because the soils for producing crops and stuff, like the quality of the soil is getting less and less and less. So the production is getting less and less and less. We have a water frame directive, meaning that the water has to become of a certain amount of quality. And in the Netherlands, only 5% of the waters complies to these standards right now. So that, again, in the future, and already next year, can create big problems in building projects, etc., etc. Then we also have nature. There's also a lot of legislation that we have to protect nature, because if we don't do so, people of all over the world, they start to basically they put them for court, they put governments, etc., for court, that they demising basically the need for humans, or the possibility for humans to thrive. And they're getting right by these problems. So these are problems that we really have to tackle. And for this, so only for the planet aspect, we made our systems engineering model. It's called Sustainable Systems Engineering. And I will show it to you right now. So it's a deep dive a little bit into the main aspects. So basically what you see here is that the planet, that's the one that we've taken out, but you can also see there's always people and profit there as well. So you can also go into depth for those ones and see, okay, how can you operationalize those things? And if you see all the on the left, you see subject, and you see all the underlying functions every main sub theme, like energy, resources, soil, water, and air has. And these are not all the ones, but it just gives you an idea of where you can think of if you look at those parameters. And if you don't have the information yourself or don't know how to use it, you can always fly in an expert on these topics to do so. And we first have to fill it in with a tree, because if you look at a tree and you look at the functions of a tree, you will always see that the functions are always beneficial to our environment and to ourselves. So if you look at energy, it just uses photosynthesis. So it uses its direct energy that it gets. It doesn't need any additional energy. When it grows, it stores the energy in its wood. It just uses sunlight. That's its energy needs, no any other. It's fully circular. It's fully bio-based. It gets all its resources from a local source. If you look at soil, it improves the soil. It improves the permeability. It gets pollution out of the soil. So yeah, I can go on, but all the functions that a tree has are beneficial. And as a systems engineer, maybe you find this interesting, but there is an example of a living bridge in Asia. I think it's in India, and they've basically grown this bridge over time. So it's fulfilling the function that you can walk over it. And of course, like if you want to make a very long bridge over a kilometer of sea, of course, then it's not possible. But it's about the idea that using regenerative systems as much as you can when you develop systems, the less harm you're going to do and the more beneficial functions that system eventually will have. But then if we take a car, for example, in its use phase, you will see that energy generation, it does a little bit because you have a small battery, but for the rest, it doesn't generate energy. It only uses energy. It has a very small battery where you can save a little bit of energy, but the most of it is just discarded by driving. It has a high demand of fossil fuels. It's not fully recyclable. There's no bio-based materials in there. The materials that you use come and are shipped from everywhere all over the planet. From often, it doesn't have any benefit to the organic material in the soil. It only decreases the permeability. So if you do an analyze through the system, you will see that a lot of the systems that we build have no actual benefit. And then if we take an electrical car and we think, oh, that's very sustainable. But if you really do the analysis, like it's not so better, or it's not even that much better at all, because of course, it does a lot of things on air because it doesn't emit CO2 emissions and nitrogen emission. But to water, there's no difference. The soil, there's no difference, maybe even more, exactly as you can see here, because the electrical cars are a lot heavier. And also you need more resources for the battery, which are hard material, which also have often social issues because of child labor, etc., where it all comes from. And on energy, there is a little bit of benefit, but so it's, again, an electric car is doing less bad, so it's a little bit more sustainable, but it's far from regenerative. And also the total energy amount that is needed is also higher because the cars are getting a lot bigger and a lot heavier. So therefore, we sometimes just missing the plank. But I hope this is a little bit logical. And so basically, this is what we can use this model, because you will see this in every physical system that you have. You always have to do with materials, with energy. You're doing something with soil, water, air, and biodiversity. And when you look at the planet aspect, of course.
Yeah, and
so
then
summarize the.
Yeah, and then of course
Great.
the next step is how can we use this model, put this model into use to improve on the planet aspects, to create systems, add functions to the systems that are beneficial for the themes on the planet. And we try to do this also in our systems engineering training and in a case study that we have. And I want to show a piece of that and give you some examples, but also then in smaller groups to think about this and see, okay, how can we use this model to create a system that is more regenerative? Maybe best if I take over the screen now.
Yeah, that's better.
Yes.
For sure. Yeah.
All right. Okay. So 1 moment. Yeah. Okay. So we have a case study of a park in a municipality, and a municipality that wants to attract young people or young families to settle in the area. That's their ambition. But the houses in this area are very old and small, and also park maintenance is overdue. So it's not very attractive to go live there. So there was a decision made by the municipality to create a separate storage space for the houses, so they can make use of the storage space. They have more room for their goods, and to renovate the park and make it more attractive for visitors. And the storage complex that will be integrated in the park. So there will be a storage complex in the park that the people living in the houses can make use of. But the municipality also has high ambitions on sustainability, and they want projects to contribute to the sustainable development goals, and preferably create regenerative systems. So also thinking about how can we make a storage complex that is regenerative. And we make use of this SSE model that Sies just showed to define functions and integrated solutions on sustainability for this storage complex. So I will give you an assignment to analyze additional functions, but I first will give a few examples. So this is a picture of the park and the houses. That's also in your assignment. And if we take then the planet themes like energy, resources, soil, water, air, and biotic factors to see, okay, what kind of functions can we add to this storage complex and how can we, develop this? So for example, if we look at functions and systems, and which system fulfills these functions, we say, okay, so the storage complex on energy should provide energy positive storage. And that means that we can think about from this model about energy generation. So, okay, we want this storage complex to generate sustainable energy. We want this storage complex to store energy, locally store energy, and maybe also to reduce the energy need. So, for example, to retain heat. And I say, okay, we can add like solar panels or heat pumps. We can add battery or insulated building envelope, and these contribute to these functions that we kind of derived from this sustainability model. So we can add as requirements also to the storage complex that it shall have a battery that is able to locally store the energy for the storage complex itself. And in that way, we can use the model to think of every theme and every aspect and every function that we can add to our system. For example, also for the biotic factors, stimulate biodiversity in the area. How can storage complex stimulate biodiversity? Well, it should at least make sure that local biodiversity can thrive in the area. So, for example, by reproducing, creating nesting possibilities, or providing shelter by integrating natural elements in the building, by food production, for example, ensure food production in the area of the storage complex. How can we do that? By integrating nesting facilities in the building, by creating an overgrown building where flora and fauna can shelter, by maybe planting fruit and seeds producing plants on the building area. So there we can also see, okay, we can add things to our storage complex that directly fulfill these functions. So if we fill this in the model, we can say, okay, for every theme, we can think about functions that we can add, make them more specific for our system, and also look at what solutions can we think of that. But we want a positive impact on the complete planet. So as Sies already said before, it's not cherry picking, but seeing how can we make sure that we do things that we have positive impact on all the themes. So what I want you to think about and to discuss in your groups, if we look at the other themes like this, what can we add to this storage complex to make sure that we have a positive impact on these planet themes? So that's the exercise. There is a file where you find the model and basically these figures for all the aspects. I don't think you can do them all, so you can pick with your group if you want to talk about resources or soil or water or air. And I think, I don't know if that's possible, if we can visit the groups, but maybe we can take like, it's already 5:45, but at least in European time. Take like 10 minutes. Is that okay, Hamza? I don't know how long you want to continue.
Yeah, we can do 10 minutes. How many breakout sessions should I do for breakout
like
session?
three people per
3 people?
room. Yeah, I
When
think
we are
2 to 3
20,
people.
we are 21.
Oh, well, 4 is also fine. 4, yeah. Okay, make 4 or 5 rooms. Yeah.
If you find it difficult, then you can always use Google or ChatGPT as your specialist on the topic.
Yeah.
So that's fine to use, of course.
Yeah. And if you can share the file, Hamza,
Yeah,
then,
I just sent
then
it.
people,
Yeah,
okay,
I just
then people can
sent it in the
fill
chat.
in the results in the file. And then
Yeah.
I would like to combine it in my end model.
Okay.
And when we have filled this in, then I will save it, and tomorrow I'll go to the municipality and present them our results.
Yeah. So did everyone get the file? I'm not sure if it's will stay there when I send you to the breakout sessions. Okay.
So it's good to download it now already, you mean?
Yeah. Okay, I will open the session in 3, 2, 1. I will also go through the rooms and see if everyone has the files and so on. All right.
Perfect.
Did I do it manually? Okay. Mhm. Hello. I just wanted to check if you did get the file for the assignment. Did you get it?
Where do I find that?
Yes, we have the file.
Okay. Your colleagues from the group have it. Then I will jump to the others.
Where is it?
Someone can maybe share it and then you can work together.
I'm happy to share. Okay.
Okay. Mhm.
It's still in the chat.
Okay. It
Okay.
looks good. I will jump to the other one.
There we go. Can you see the slide?
Thought he said.
Well, if you look at the examples, it just says something about energy locally storing or retaining heat. So maybe storage is just.
Well, there are lots of things that can be stored, and it looks like it's
Yeah, it
extending the
seems to be
concept of
general.
storage, which is good.
You have the assignment, everything is going well, so you're already in the discussion?
But did you get it? What storage complex is?
Not exactly. Wait, let me see.
If you see the example in the storage actually complex, they mentioned from the actually facilities to maybe other things
Yeah,
that they can also produce plants. So it means that maybe they have everything in the storage.
yeah, I don't know. I think it's just like a storage, like a box of something that you can store something, and I think the idea is like to use it as a thought example.
I mean, certainly the park itself, the overall complex can be regenerative.
Just as an example, I thought that in the water area, which you didn't talk about, there could be
to fulfill that functional requirements.
I will come back to you. We'll ask Bart and come back to you.
Okay, water filtration.
Yeah, so just make the box bigger. You can just pull it down.
Yes.
Yeah.
Do that.
Hey, Bart, could you please go to room 3? They have a question on the storage complex.
Okay, how do I go there?
I think if you go to the breakout session, can you click on the breakout session or not?
No, I was just thrown into this room.
I will just like send you there. Right.
Okay.
Yeah.
Perfect.
Which one is this one?
Yeah, so maybe then if you look at the titles in the boxes, we have water need and use, water storage, and water quality. So we talk about water filtration. That would be the third box, right, on quality. And you put the function beneath that, and then in the green box you put the solution. Yeah.
Okay.
Okay.
But
Can
I
you
will
send
send you
me to the other room?
Yeah.
So for for the water storage part, if you're going to use the water houses, it's a plant. It needs light. So water storage would mean that you'd have to have some open water outside the building, retaining ponds. And then those retaining ponds is where you'd have the water hyacinth.
Yeah.
Hello, how is it going? Do you have?
When you come with the recording in progress.
Well, we're
Stop
still
it.
setting the
That's the
system
solution, isn't it?
boundaries.
Yeah.
Maybe you can help.
Yeah, maybe what's the question? Maybe I can try to answer it. Otherwise, I can get Sies or Bart to join in.
I don't. Well,
The system
the
is the whole
bottom of the previous
municipality.
slide said a candidate solution. We don't.
No, the system is the storage. It's like a storage system, a storage complex. That's like in the slide. If you go on slide 3.
Mhm.
So here there is like the example. So the storage complex that's on the right side is the system.
Yeah.
And then on the left side, there is the example where they are looking at the energy. How can you have regenerative energy? Like what are the functions that you need? And then what are the logical or physical components that you can add to your storage complex to provide that?
I don't think that's a system breakdown because there are solutions which are distributed. Everybody in their dwelling does a bit of what's said. Everyone contributes. That's a possible distributed system. So you want a centralized system.
I think
You
you
know what I
need
mean? You've got to think about the
centralized
architecture.
system with a, is that, are we, oh yes, we are already talking about the solar panels.
Okay.
And solar panels heat pump, is that solar panel rooftop are we talking about?
I will go get Sis or Bart to join in and maybe support you better on this.
What should it be built of? Take the example of the car. You can spend energy building it, can't you? What should it be built of? What should water and fuel consumption be?
I mean, it can be like renewable. So do you mean like the energy or the resource? So what's
Well, we've got a list, haven't we? I mean, the whole thing is if it's a complex like a building, the point he made about cars was you can expend more energy by building them than you're saving by running them. So this thing's got to be able to save energy in the building and the construction and all those things too. And you know, how is it fed? How is it powered? All those things, you know. Got to think of the whole system.
I will ask Bart and then I will come back.
Well, why don't we think for ourselves? I'm sorry, I'm shutting up.
Yeah, I'm not part of the group. I'm just like trying to moderate and support. Yeah.
Oh, it's a building. It's a building.
And you can also, if you need the water for the hands, if they're kind of use the water more effective, maybe you say one part which you use for hands or so, you can also use later for the toilets. So then a second cycle, so cascading use or so.
I would see that in on the system breakdown to actually start looking at that, because the intent is that whatever we put in the physical side on the system breakdown is what actually is helping us to achieve what we want on the function breakdown.
Okay.
Sorry to interrupt. Sies, can I send you to another group where they have some questions?
No, we like him here.
Don't take him away.
No, of course you can, Hamza.
Okay, let's see. Yeah.
I mean, thinking about things that can actually like fulfill those functions, you'll be able to do so, I guess, right? And otherwise, just use Google, huh?
Yeah.
Sure.
All right. Sorry, guys.
Cheers.
Okay.
So for use in the facility, and then reuse in the park, I guess it's the system that would actually provide that.
I like the idea that Anne had to actually reuse water throughout the system. So really think about this is the first use. It's still clean enough that I can wash my hands. It's still clean enough that I can, I won't say wash the dishes. It's still clean enough that I can flush the toilets. Now it needs to get cleaned. So it would be I would say a water recycling system or something like that.
Yes, but you still don't need to recycle it in the first place. You can
recycle is not the
you have to
right
store
word.
it. You have to store it to use it for a second time.
Yeah.
If you wash your hands with it, then it needs to be stored somewhere. When you use the toilet, you can use it again. And then
what would you call that system? So I like it. What would you call it?
Staged water system, I was thinking something like that.
Yeah, that might.
There's a name for it, but I don't know.
You then go back to slide 5 again. You would fill in that box on what I need. Okay, recycle water, and then we can think in the green box. Okay, what could be a solution for that? And what can we think of for water storage, for example?
Yeah, water tanks.
Yeah, by capturing rainwater, for example.
Yeah, capture rainwater. Yeah.
Yeah, so function could be capture rainwater. We can.
So I think we should enter this in these boxes on slide 9, right? So
yeah, that was okay. That was my idea to do plenary, but you use the separate slides to to discuss
so
and fill in functions and system. But yeah, you can also fill it right in. Yeah.
Okay, we can use these here.
Yeah.
Sorry for interrupting, Bart. I see that we have still 2 minutes. Should we add more time, or what do you think?
Yeah, if people have time, that's fine by me. But I don't know if people have to leave.
Yeah, then maybe we just get back to the plenary and then we discuss the results.
I don't know if the other groups have.
They're moving
some actual work. Yeah.
Yeah, they're moving forward. Yeah.
Maybe we should check if at least every group has one theme finished. I think we're almost there for this group.
Okay, then I will jump and see the others. Yeah. Then maybe add another 5 minutes.
Yeah.
Okay.
Fine.
So maybe we can use
about the.
Yes, Hamza.
Hello, how is it going?
Apart from the I don't know, technical bits. You go ahead, Luke. Go ahead.
Yeah. Is time about up? Are we going to debrief this or anything?
Boy.
Hamza, did you hear what I say?
Sorry?
I said, is the time about up and we're going to debrief this?
Yeah. So we just added 5 minutes, so another 4 minutes, and then we will get to the plenary and discuss the results together.
Oh,
so
okay.
Does this go over here then in the optimized part? Luke, you want?
Yeah, I'm not sure where how it all fits in there, but
okay.
You know, the whole thing is we've got to think about the storage complex is not just the building. It's the land around it.
Yep.
And so we have a complete ecosystem that we got to be in harmony with.
Yep, I agree. Absolutely.
So looks good here. You already finished, yeah?
Yeah.
Yes, I think so.
Okay.
I don't know.
We picked an easy one.
Apparently everyone picked water, so I think they
Oh.
yeah, we didn't assign the groups and so on, so maybe we will have a lot of water here. I will go check on the other groups. Maybe you
Well,
can do
it's
another one very
fundamental.
quickly. Now that you got warm up, you
Okay.
can choose another
Okay.
one.
Okay. So air quality, do you want to go? Shall we do this, Lou? And Fabio left us, or what a pity.
Of course. So maybe if we go, yeah.
That provide a habitat and offer food resources, something like that.
Yeah, store water for tap water and watering plants. Because that's the function that water storage has to deliver for its complex.
So offer food sources.
Sorry?
So, sorry, pass.
Yeah, that's all right. So water storage here, it needs to store water, of course, because if you don't have
Hi, Peter. Did you just leave the breakout room? Yeah, Bart, I think that's almost everyone, every group like picked the water one, like the So Bart, no, Bart, you're muted. Sies also.
Oh, I think was automatically muted again. All
Yeah.
right.
Yeah.
Hamza, just one point regarding my work actually that I discussed with you is the same approach that we will define the functional requirements also according to the sustainability regulations and then provide solutions.
Yeah.
Oh, yeah.
Yeah, so basically what we do here then is that we first make the functions more specific. What does the storage complex need to do? And what are then the solutions that we need to fulfill that? And then we can also, of course, add the requirements on how well the battery should do this. But that's how we kind of make use of the model by analyzing the themes and the aspects, making specific functions that can be added to the storage, and then thinking about solutions and requirements that we have to fulfill. So I'm kind of curious, did all the groups only did water, or was there also a group who did one of the other themes?
We started on air. We did water first, and then just a few minutes on air.
Okay.
But just one question regarding this work. Then you will also evaluate the functions dependency to decrease the system complexity, or no?
Of course, this is not the only thing that we do. So in your functional analysis, you should kind of combine all the functions in your let's say functional tree or functional flow block, how you want to call it, to see how everything, let's say, works together. But basically, we use this model to kind of systematically go through all the aspects and see what functions can or do we need to add to make sure we have a positive impact on all. And so, of course, also depending on your ambitions, do you want indeed to have a fully integrated positive impact, or do you want to have it on a level of not harming on each of those? But our ambition is kind of that we can visualize how systems that are developed, how they can make a positive impact on these planet themes. And you can make that visible by going through all the themes and defining those functions and solutions, and then kind of analyzing if indeed this now makes a positive impact, or what requirements we need to add to the functions to say, okay, you need to fulfill these requirements to make sure we have a positive impact. So that's how we make use of this model. And of course, then it also you need to combine all your functions in your functional overview or your functional flow block and see if you still have a fully integrated functioning system.
And maybe adding to this as well, okay, it's not the goal of this overview basically, and this model is not that you have to fill it in yourself. It's that you have an overview of all the different disciplines that you often have in a project that you need to ensure that you fulfill basically these subjects with the expertise. So it gives you a very integral overview. And I think that's the most important thing. So understanding this on a higher level just always gives you sort of like also the notification for, hey, I have to do something, or maybe at least try if we can do something with the soil, or with biodiversity, or with circularity, in that sense of our resources.
Yeah.
Just one of the maybe challenge in this approach is that it totally depends on the experts that are developing this work, because according to their knowledge, you can achieve different functions and different solutions, and it needs kind of a recursive analysis to be sure that all the functions are already defined well, and also how they can also impact on the other aspects.
Yeah, of course.
Thank you.
And of course, we always depend on the experts that are available or that are involved in a project. But at least this helps us to make sure that indeed we look at all the aspects and not just a few, or that we're not doing cherry picking on one of these things. And of course, you have to challenge everything that will be filled in this model and go through them. But at least it paints you the picture of what we're doing on all these these themes.
Sorry, I have an organizational question. So Bart and Sies, how do you want to proceed? So I feel like kind of the discussion is like, do you still have some slides to show, or is it like already at the end and we can open the discussion, or how is it?
I had one last slide. I would like to at least, well, if we all did the water part, maybe to fill it in and see what we came up with.
Okay.
So maybe ask one of the groups. So what did you fill in as a function that we can use for decreasing water need and use?
Yeah, Yeah, Lou has his hands up. Lou, is it about
Mhm.
the exercise, or can it wait until we get to
Wow.
the Q&A part?
Yeah, I had two comments. One is in the previous part of the presentation, they talk about needs and then requirements. And here you're talking about functions and requirements, but it seems like you need to talk about needs instead of requirements. And then from the needs, you develop the requirements.
Sure. Yeah.
The second thing is when we were doing the water thing, my mind kind of works as an integrated system. And so a lot of what we talked about water had to do with land around the building.
Mhm.
And so there's a biotic soil, water, air, kind of were all intertwined to do that. So when we were talking about water, the key thing is we want to minimize the inputs and minimize the waste outputs of the whole system. So we're going to reclaim the water whatever we
Mhm.
can. We're going to
Yeah, very
reuse
good.
the water.
Yeah.
We're going to have, there's going to be different requirements when it comes
Yeah.
to gray water use versus water for human consumption.
Yeah.
So there's going to be different filtering um, needs
Mhm.
for that. Hopefully the gray water filtering, we talked about having ponds, and in the ponds would be, there's a plant that I know is commonly used called water hyacinth. It floats on the top of the water and it filters out impurities from the water. And I think it's used several places around the world already where they have fairly large ponds of water hyacinths. The water flows through it. But the water coming out, I'm not sure it's totally human consumable yet. It would definitely be okay for gray water. So I need two filtrations, an additional filtration system to make the water, for human habitation or consumption.
Cool.
The gray water wouldn't have to have that special filtering, just through the water heights probably be enough. And from a natural standpoint, the waste is consumed by the plants, but the additional filtration system for human consumption, is that waste consumable by the plants, or is it hazardous and it would have to be, go out from the system? But the landscaping, you'd have to have it set up so that you'd minimize the water, any runoff away from the property. So you'd want the land, all the landscaping to be able to hold water a certain amount, and then any runoff would go into these ponds. Um, uh,
Sounds like quite a good solution, Lou.
yeah. So there's
So
a
I
whole
tried
lot associated with that.
to write along and also think about what I saw in the other groups. And these are kind of things that we can fill in. So you're completely right. We talk about the needs. So we say, okay, needs come from the planet. And we have to think about all these themes if we talk about needs from the planet, as the planet as a stakeholder. And then we say, okay, we can add functions that contribute to these needs. And the next step is, of course, also to translate that into requirements. And we say, okay, what requirements should be fulfilled by the solution to make sure that we can fulfill these functions and fulfill the needs of our planet. So that's indeed the same kind of approach as we try to do here, to translate needs of the planet into these themes, into functions that you can add to your system, into requirements and solutions.
Now, when I have a table like this for people, so that because people have needs too when it comes to sustainability. And so I would have a similar drawing like this where all the lines came out of the people's part of it.
Yeah, sure. So what we did now is, let's say the first part of the model is the planet part. And we also have the people and the profit part, as Sies explained in, let's say, this picture, right? So basically, we're now focusing with this exercise on the planet part, but of course, to be fully integrated, you should do all three. Yeah. And if we go through all the themes, this would be fully filled in, and that way you can assess, okay, with all the things that we're doing, do we now create a storage complex that makes a positive impact? But for example, if that's not possible, of course, you can also increase your, let's say, system of interest. So if you say, okay, we create a storage complex here, and for parts of this, we can make it regenerative, but maybe for other parts not, you can think, okay, what are other things we can do in the park to create a positive impact as we look at the whole. So for example, and that's of course a simple solution, but we saw that in Sies' picture that the tree, that was this one, has a lot of positive impact. So we could also, of course, compensate by planting more trees if on parts we can see that the storage complex still has a negative impact, but we can compensate this with trees. So there's lots of things you can think about. Of course, the main focus is what can we do for the storage complex itself to make it more regenerative, and where we cannot do that, what are other things we can do within the project to compensate this.
Bart, can I ask a question?
Sorry,
And
sorry,
Anna as well.
Peter. Anna has been raising her hand for a while.
There's a sore hand right now, yes.
Is that me?
You're muted, Anna.
How do you do trade-off? Because
Peter, we will get to the question from Anna, and then we will come back to you.
I'm in delayed action somewhere, but I do beg your pardon.
Yeah, a question to Sies and Bart. Just an added thought. A planet is a very big thing. Would it be maybe a little bit easier? The park is an artificial part of nature and part of the planet. Maybe to think of it as a non-human persona. So, and then to say, okay, this park named Paul also has needs. So what do we do to have the storage would because yes, to think of a planet and a park is a very little small part of it. Was a little bit overwhelming. So that was maybe a good example for a non-human persona to work with it. That's it.
Yeah. Well, we gave it a name. We call it Sies because my colleague Sies sometimes has an outfit with a planet picture on it, and then playing the role of stakeholder planet, and I think that is what you should do also in your project. Have someone basically representing the planet as a stakeholder.
Thank you. Yeah, Peter, you can go on.
Well, I'm going to leave in a minute, but I was just wondering, and you almost touched on it just now, it's about scope and it's about trade-off.
Yeah.
And can you quantify those factors? And if so, how do you trade local for regional and global? I'm not trying to make it too complicated. It's easier to write the factors down than it is to trade them off.
Yeah.
They're all nice to have, aren't they?
They're not nice to have for sure, because if we look
at, can't be all essential.
If you look at in the Netherlands, for example, or in Europe, like if you look on the ecosystem functions, like within here, like we have problems with sustainable energy, we have problems with our soil, we have problems with our water quality, we have problems with our climate, we have problems with our biodiversity. So they're not nice to have, they're essentials to have on the long term, because if we the longer we wait with fulfilling them, basically, the more it's going to cost to restore ecosystem, or to filter water, or to clean the soil, or to improve the soil again.
Yeah, I would rather say they're constraints than they're nice to have. Basically, our opinion is that we have long past the point of doing less harm is good enough. So at least it should be zero, or it should be positive. And but but that's of course depending on the ambition of an organization, like in this example, the municipality, how far you want to go. So it's also depending what's the ambition that you want to fulfill, and you can make use of this model at least to visualize
At all
this.
those points. We live in a political world, and we've got child poverty, and we've got social anxiety of teenagers, and we've got a roaring adversary on our doorstep. I'm just saying everything's tradable. Has to be.
Of course. And if we can make for all three visible what we're doing on all the aspects,
I agree.
At least you can make visible if we have a positive impact on all, or if we have positive impact on some, but a negative impact on others, and how we can compensate this.
I think your work makes everything visible. Got to go, but do thank you very much for the talk.
All right. You're welcome.
Yeah, thank you.
Thank you, Peter. Ali.
Just following Peter, actually, the question regarding trade-off. One thing which is important in this axiomatic design work is defining measures for each functional requirements. So if you define measures for the functional requirements, then you can trade off between alternative solutions that you can propose for each function. Then according to maybe the budget and also different criteria, you can define and select one of the alternative solutions that you can propose for satisfying functions. So just one thing which is important when we are doing this kind of work with axiomatic design is important that define measures for each function. It will help you to distinguish between functions and also define the best solution.
Yeah, I fully agree. So, okay.
I have a question.
Yeah.
Thank you very much for the presentation. I mean, it's very cool, and especially like your tool is super accessible. Like it's not so complex and very accessible to any stakeholder. They don't have to be engineers or something like that to give them a good overview of what needs to be done. But then, like if we take like a company's perspective, like a profitable company that think about profit. So we see now that like the storage complex with all these different perspectives and the different functionality that are added. So the complexity just like adding, like increasing like crazy actually. And the question that most of management people ask is like, how much money is going to cost me and how much money am I going to get from it?
Yeah.
This is a valid question, and maybe because like normally I give trainings in regenerative systems. I developed it myself, but I arranged with Dutch Groeten, so with my company, that I can do it in trade-off for trees. So people have to donate trees, and then they can join the training. So we're actually making like within this business model, because we have different business models, also business models that make money, but with this one we don't. But what we actually see is that people find this so inspiring that they actually want to work at our company because we do cool things. So I think it's very dangerous to think that only your financial benefits is also one-on-one comparable to the future proofness of your company. So eventually the financial aspects of your company are also basically decided by the underlying values and what you actually want to do. So I think that's also very important to see and understand, that also looking at the future, companies that actually create societal value and environmental value, they're often rated better. Like even if you look at the stock market, like the sustainability stocks basically did better than the conventional ones. So yeah.
If we go back to this picture, then maybe Hamza, with your question, you're still living a bit in this world, right? Where we say, well, okay, you can make money, but if you don't have an environment to live in, you can make money whatever you like, but in the end you have nothing. And if we look at the assignment, the first thing the municipality said, we want to attract young families to settle in this area, and that also generates money. So yeah, maybe it costs money because you have a more, let's say, expensive building because we're adding functionalities to it. But in the end, it's something that will attract more people that want to live there. That was your goal. And of course, you have to make this trade-off. There is, of course, somewhere let's say, a ceiling on your budget, how you say that. But yeah, and it doesn't have to be. Maybe, and how we currently fill it in, we're just adding things that are extra, of course, extra money, but it also makes you think, and how can we maybe do things much simpler, or maybe don't do certain things. And it doesn't always mean that it gets more expensive. And of course, yeah, it's always depending on how you value a regenerative system. Yeah.
Maybe it costs money in the first place, but then it often saves a lot of money in the long run, because sustainable solutions are also often thinking about the future. Now, for example, in the functional lab in Rotterdam, all the building projects, like there's so many projects where the soil is so polluted that they first have to pay millions basically to get rid of the soil before they can start to build. And they didn't put those costs, the companies that spilled all the pollution there, basically, they didn't think about it, but then they basically shoved the problem towards into the future. And that's what we often see. So yeah, companies need to start thinking also differently, that if they don't invest in sustainability, the financial cost will eventually come back in the long run. Because people, and especially our society, they were going to demand from it if we pollute or keep polluting our environment more and more, because it's their human right that they have an healthy environment. And legislation should become harder.
John, you have a question, or you want to add something to that?
Sorry, John. I think Lou had his hand up.
Okay.
Yeah, that's right.
I didn't see it. All right, Lou.
Another comment. Requirements. The word requirements is very ambiguous as to what you're talking about, and so we talked about in the requirement working group, talked about requirements on the system itself, but also requirements on the organization and requirements in the process.
Mm-hmm.
And so when you use the word requirements, and you don't want to mix those, when you're documenting those. And I did a previous presentation on sustainability needs and requirements. And in the first evaluation, I found the majority of the needs concerning sustainability were actually on the organization, on the people, because it's the people that make things sustainable. And then you can allocate some of those, to the system under development, and then you'll have system requirements. But the people, the requirements on the organization and the developers, are equally important.
Lou, I agree, and we always make this distinguish. Yes, so when I was previously talking about requirement, I think I was talking about system requirements. So what should the system do, and how should it perform to be more regenerative as a result of the system? But of course, we also have requirements on how the organization should operate, how people should act, what they should do. Yeah. And we always distinguish these requirements indeed. Yeah.
That drawing that you showed in the other slide deck, where you showed continuous verification validation across the life cycle. That drawing basically came from the drawings from the requirement working group. That we developed a similar one, but we've added underneath what we call design controls. And those are a set of requirements on the work people building the system. And so if you don't have the requirements for those people that are defining the needs, the requirements, that are doing the design, doing manufacturing, concerning sustainability, and all their work instructions and their processes and stuff, you're not going to end up with a sustainable system. So
good addition.
So that piece should probably be included in your drawing. So the design controls are shown at the bottom.
Yeah. Thanks.
Thank you, Lou. John.
Great presentation. Thanks so much for putting this all together. Sort of
Thanks.
reflecting on this, it seems to me like the economy is really a means and a mechanism by which we allocate resources to deliver the greatest possible value over time. And if you think about it, there's this notion of sort of cash flow that we talk about in corporations, and we also talk about sort of the balance sheet in terms of assets and liabilities. And one of the things that we just don't capture with respect to the environment is what's the overall balance sheet that we have for the world in which we live, right? Because if we keep essentially consuming, we are reducing our assets, right? And this thing has to balance out. And then there's sort of shareholder equity, which is kind of the equity that we have as a human race, if you will. And so thinking about it, there's the question of the short term versus the long term. If, for example, we spend all our money in investment and nothing into actually producing food that we need to eat tomorrow, we'll all starve, which is sort of like a cash flow that we just aren't able to sustain. So I think looking at this, the question is, how do we build sort of shareholder equity, which is this sense of the long-term value that we're creating. So as we talked about this park, we want to invest in clean water and these sorts of things. There's the positive aspects that we're going to get from that, and then there's the short-term aspect. But if we look over a long enough period of time with the right sort of rate of return, we can determine how much shareholder value that we're actually creating for all of this. Now, our economic system is horribly unfair in terms of how it delivers those resources. But in theory, that's what the economic system should be doing, is creating the maximal value, for everyone on this
But
planet.
what kind of value are we talking about? Is it zeros and ones in the sense of financial, or is it values? Because I often ask people in my trainings, like, what makes you happy in life? And they always come with values like friends, family, contributing something towards society, etc. So it's things that actually they don't never come up with cars or an expensive cars or want a huge house or anything. So it's very essential about how do we define value and what is actually valuable in our lives. And we've been, especially in Western society, we hang up value to the welfare and the amount of money that we have. But as we saw in a minute, I think it's just means basically that you can use to become, you can have all the wealth in your world, but be unhappy as hell.
Oh, absolutely. I mean, the current system is just consumptive. It's just a purely consumptive measure. Sorry, Adrienne.
Yeah, sorry to interrupt. I don't have my hand up, and I am leaving soon. But I just wanted to jump in there because I think, if I've understood your conversation, John, is that you're really wanting to factor in what's the value of the natural capital of a country, and so we don't factor in the cost of the natural capital into the cost of goods and services that we purchase. And if we were to do that, then we wouldn't be able to afford anything, actually. So for example, the extraction of oil, we don't factor in the cost of, we factor in only the human labor, we factor in the pipelines, we factor in the mechanisms to build the pumping and the material, all the infrastructure, but we don't factor in the natural capital, all the land that we go through, all the air that we use, all the water that we're using. So we don't factor in that, and that's been a big source. In fact, the UN have put together a great free online course about environmental accounting that looks at some of that, if that was to interest you. But so I'm just, is this what you mean? Was that about?
Absolutely, because we keep talking about the economic system like it's this thing that you can't change. And the point of the economic system is to help us do things that are going to create the maximal value over time. That's the whole point of the economic system. Yet, if we have an economic system that's focused only on consumption, well, we can see what we're going to get. And we're starting to see now the economic effects that we're getting because we're not treating the planet nicely, right? And those are just going to increase. I mean, the amount of damage that we see from weather and so on and so forth. So we're making very, very poor economic decisions because our current economic system doesn't do the accounting properly. And we need to move to a system that does more proper accounting so that we can actually make decisions that make sense.
Right, but the really forward-thinking companies are actually thinking about where do we want to be in 100 years' time. And I'm talking about companies, big American companies like Mars Corporation, the privately owned one, and I think it's one of the biggest privately owned food companies in the world. They make Mars bars and Snickers bars. You know those products? Are you familiar with those chocolate products?
Of course.
So they have invested, or they are investing, millions and millions of dollars into not just regenerative agriculture, but also thinking about the chocolate, where the chocolate farms that they are buying in Africa. So their forward thinking is, if we want to be profitable in 100 years' time, what do we need to do today to ensure that our company is still running in 100 years' time? And you are finding companies that are factoring in those components, where they're factoring in particularly climate change and water and air and social aspects, to their belief that they will only survive as a company unless they think like that. And so you're getting more and more companies, very large companies, who are thinking like that. So it's not completely hopeless. And the good news is that these very large companies intend to be around in 100 years' time, and they understand that that intention can only be delivered if they factor in those risks, because they are risks. They just haven't factored in the natural capital cost into a Snickers bar. So I'm sure that's coming, but they haven't done that, and no company does. But
I mean, most farmers used to be like that, where it was understood in the family farm, you were going to pass the family farm down generation to generation, and having a family farm for 100 years was not unimaginable. Actually, it was fairly commonplace, but of course, that's changed. Hamza, you have your hand up. I'll back you.
Yeah, sorry. Sorry to interrupt the discussion. I just have to drop off. I don't know how it is for Bart or Sies. I could
for me too.
leave the room. Okay.
Yeah, it's almost dinner time on this side of the ocean. So
okay, then maybe we just do a closing. A big thank you very much for this presentation. It was great.
You're welcome.
You are part of the working group, so it will be good to see you. We will definitely use your work. If you can send us some slides and stuff like that, we will definitely look into integrating it in our approach. I already sent you the onboarding slides. So we have this practical project where we will be implementing these kind of things and seeing how to qualitative and the quantitative measurements and trade-offs and so on. So Lou has had some ideas, Ali also, and I think we will get these things into, implement them somehow, bring them together.
Okay. Thank you.
Good.
All right.
Yeah. Thank you everyone for joining. Thank you for the discussion and the questions.
Thank you.
And see you next time.
Have a nice rest of the day. See you.
Ciao, ciao.
Have a great
Bye.
day.
All right, mate. Bye-bye.